Good afternoon. Good afternoon, guys. We'll be starting the session in another 5 minutes. Okay, let's just wait for another 5 more minutes. We'll be starting the session. Good afternoon, everyone, guys. Good afternoon, everyone. Okay, so I think everyone is here. So I'll be starting this session, okay? See, Jagadish, the thing is, it's not like almost 7 minutes. So initially, we'll be giving a buffer time for 5 to 10 minutes, okay? To let everyone join. Okay, not everyone will be joining on the time, right? So to let everyone join, initially we'll be giving a buffer time for 5 to 10 minutes. So that is the reason, okay? It's clear for you. Guys, okay. So, what are all the topics that we have discussed yesterday? All the topics that we have discussed yesterday, guys. We were done until base theorem, correct? We were done until base theorem, correct? Yeah, sampling we have discussed, correct? And we have discussed the quantitative, qualitative, right? The types of the data, right? Yeah, statistics for machine learning, but we are not completely done with the statistics, correct? Yeah, hypothesis testing we have discussed, which is very, very important. Yeah, hypothesis testing is for grouping. Okay, so and coming into attendance part, guys, you people know that, right? At 3:30 exactly, I'll be sharing the link, and it will be active for 1 hour, and then in that 1 hour time period, you can do your attendance, right? You people know that, right? So please don't ask multiple times. Okay. Okay. Last class recording in the YouTube for easy access. See, more, each and every day you'll be having all the recordings, right? So please try to visit the same channel so that you'll be able to get a hold of the last class recordings. Okay. Okay. Yeah, I'm sorry for that, Srinivas. So yeah, I didn't share the collab notebooks. I just got to remember right now. Okay, I'll be sharing. Okay, I'll be sharing that by 5 o'clock. I'll be sharing. Okay. Okay, I will just inform the team Mohan regarding this last class. Okay. Regarding the last class, I just inform that. Okay. Fine. I'm sharing my screen. Let me just share my screen. Okay. So whatever the queries you are having, guys, please keep all the queries to you. And when we are able to discuss, or else we were able to have a break, or else at the end of the session for the last 10 minutes, you can ask all the queries. Okay. So during the time from 2:30, that means like 2:40, 2:40 to 4:20. Okay. 2:40 to 4:20. Please ask the queries if it is urgent, or else if you want to immediately know, or else drop the queries which are related to the topic which we are discussing, so that I can go through those questions and I can answer them. And whatever the other queries you're having, ask after 4:20. Okay. Please do that. Okay. Okay. So hope it's clear for everyone. Yeah. Okay. So base theorem is done, and there is this central limit theorem. So before understanding the central limit theorem, we need to understand how a normal distribution is. Okay, how the normal distribution is, how the normal distribution will be happening. Okay, so to understand the normal distribution, we will be going into this. I'll be enabling this MS Paint. Okay. Okay. So let me just try to, yeah, it's fine. So what are we discussing? We are discussing about the normal distribution, correct? Normal distribution means, so let's say I'm having a column. I'm having a column. So in that column, I want to draw the plot. Okay, if I want to draw the plot of that particular single column, so it will be values followed by the value count. Value count in one axis and values in one axis, right? So x and y axis, correct? X and y axis we'll be having. Then after this x and y axis, what is the next thing that we'll be getting to have? So the plot of that particular, data, right? Or the column. So this is how, not exactly. So this is about this normal distribution plot, okay? So in normal distribution, what happens is the data will be normally like it will be distributed in a flow format. Like this particular kind of distribution, this distribution, whatever you are seeing, the distribution, the graph, it is in a bell-shaped format, right? It is in a bell-shaped format, right? So normal distribution means the plot will be in a bell-shaped curve. Normal distribution, the plot will be in a bell-shaped. Normal distribution. Normal distribution will be in bell-shaped curve. Okay. It is a bell-shaped curve. How to identify if my data is normally distributed or not? So if my plot is in this format, it is normally distributed. Okay, it is normally distributed. So 1 minute. Okay. So I told this is a normal distribution, right? Normal distribution. So this is how the normal distribution will be under x and y axis. Okay, under x and y axis, that is how the normal distribution will be. So if our data is distributed in this way, like in this plot, then we'll be saying like normal distributed. Like so, let's say it is a bar plot. So what happens in bar plot? So let's say this is let's consider this as a column. Okay, in this column, the values are over here, and the value counts are up to here, and the values went up to over here. The value counts will be in this range. Okay, so this thing will be divided into quarters. Okay, quarters. This thing will be divided into quarters. Quarter 1, quarter 2, quarter 3, and quarter 4. It will be divided. But before understanding what exactly are these quarters, we need to understand what is skewness. Okay, skewness. Skewness. Let me just write. Skewness. So skewness, we'll be having two different plots. Okay, but I will explain what exactly is skewness. But now just consider skewness. Not consider. This is what it is in skewness. Okay. So let's say this is XY plot, and if I try to draw that particular normal distribution curve. So my data will be, I can get a plot like this, or else I can get a diagram like this also. I can get a diagram. These two are different plots, okay? These two are different plots, okay? Whatever the plot I'm trying to do, I'm trying to get this type of graph. I'm trying to get this type of graph. And initially, if I try to plot the things on my particular column, I'm getting this type of thing. So from here to here, there is no growth, and from here there is a sudden spike, and it went up to here, and this is for the whole quarter. From here to here, there is a huge good production, and from mid month there is particular no particular production which is happening, and the line is completely flat. Correct. So let's consider this from point as 12 months. Okay, 12 months. Okay, so now we will divide that into quarters. Okay, so quarter one, quarter two, quarter three. Okay, so from quarter in between quarter one, what are we able to see? We are able to see like the, let's say, price and also product. Let's say this is the product and these are the sales. Okay, so there is for the product there is no much sales, and the sales are flat lying on at one single point. Correct. In quarter one. In quarter two, we can see from one point to another point the sales have been raised, right? The sales have raised. Correct. So if you see for the third quarter, they have significantly raised. And before diving into fourth quarter, the sales went up to a maximum, and it got down to completely low, back to as per the quarter one pricing. Correct. So correct, right? So are you getting this? So now my data is not normally distributed. If I build the model on this kind of data, if I build my model on this kind of data, I can say like my model will not be able to learn good pattern. Okay, it will be learning this kind of data. It will be learning about this kind of data. It will be learning about this huge spike. So mostly, what are all the major data points which we are having? It will be learning mostly that. So mostly, we'll be having these data points. So now my model will be learning about only this part. So it will not be able to learn about this part, or else even if this part is available also, you won't be getting a good model, okay? Because whatever the data I'm having is not good, but whatever the input which we are getting, maybe that could be relevant, correct? If you try to do predictions on that particular newly unseen data, what happens? We'll be getting a wrong output also. So we'll be getting a wrong output also in that time. So in order to make sure we are not doing those kind of mistakes, we'll initially try to make sure our data is being normally distributed. Okay. So this one from here to here, right? Left side to right side, we are seeing from left to mid of the left, there is no spike, and from mid left to if you go to the full length of right, there is a huge spike happen, and the price has come down already. So this type of plot, okay, this type of plot is known as left skewed, okay, and this one is called as right skewed, okay. This is left, this is right, okay. So skewness is nothing but this part. This part is called as skewed. Skewness is nothing but called as, that particular part is known as skewness, okay. Okay, hopefully everyone understood this skewness, right? Any doubts, anyone? No, right? I have seen 5 hand raises, say 7 hand raises. So if you are not having any doubts, it's fine. Okay. So for each and every topic, I'm just getting a confirmation. Okay. Okay. Fine. Just a moment. Okay, we're done with that skewness part, and coming into this normal distribution, I told like that should be in a bell-shaped curve, right? How to identify normal distribution? It will be in a bell-shaped curve. Okay, and one more thing is in that normal distribution, there is a concept called confidence interval. Okay, there is a concept called confidence interval, which is very important. Confidence interval is nothing but so directly saying that a certain amount of data which is in a certain range is present in that particular range only. So it's like if my data is normally distributed, I can say the data is 96% of the data is present in this particular region only, this particular area only, in between quarter 2 to quarter 3. So if it is normally being distributed, so mostly if you see, this is what you will be seeing. Okay, mostly so normal distribution, the confidence interval. Try to check regarding this confidence interval. Confidence interval is nothing but it's like making sure and saying that 96% of the data or else most percent of the data lying in this particular region only. Okay, so that is what exactly the confidence interval is, and yeah, confidence interval is a confidence interval, and also yeah, let me just go through the PPT. Central limit theorem. Central limit theorem is nothing but distribution of the sample mean, large sample size, and statistical inference. Statistical inference. So what exactly that does the central limit theorem mean? Central limit theorem says that central limit theorem says that the distribution of the sample mean. So entire population is nothing. Entire data set is another population, correct? And if you are considering only a specific observations from that particular whole population, then we will be calling that a sample, right? So whatever the sample data which we are considering, for that the mean, whatever the mean, we'll be calculating the mean. Okay, for that, whatever the mean, it will be equivalent to the population mean. Okay, it will be equivalent to the population mean. So that is what the first point is saying about. Okay, so now coming into this larger sample size. Okay, so the sample mean here it will be normally distributed, and also what it is saying, the theorem holds true when the sample size is sufficiently large. So when the sample size is sufficiently large, what it is saying, the theorem will be like it is saying that the graph is normally distributed. Okay, so mostly what this central limit theorem will be saying about is sample mean will be normally distributed. One thing is sample mean will be normally distributed. It will be saying about sample mean, and then it will be saying about the sample mean will be equivalent to population mean. Okay, the sample mean will be equivalent to population mean. Okay, population mean and sample mean you're getting, right? Okay. And coming into this plot in the OneNote. So in this graph, in this plot, let me just draw the plot again. So now we are going to discuss about this standard deviation and variance. What is standard deviation and variance? And skewness, we just got to see about the skewness. And one more topic was outliers. Okay, outliers. I just explain outliers now. Okay. Now I will explain outliers. So this is the plot, okay? And this is how my data is, okay? This is how my data is. So if I want to do if I want to check I'm having any outliers in my particular data, what I'll be doing is I'll be going for a box plot, okay? Box plot will be something similar like this. Here will be the data points, and this is all the data points. So why I'm getting a box over here? Because that means that whatever the range which is from here to here, from here to here, in this area, there were more data points. Okay, there were more data points. More, okay, more data points. And what are the data points which is here, which is here? These will be the outliers. Okay, the data point which is present far away from the other data points. Okay, the data point which is on far away from the other data points, that we will be calling it as an outlier. Okay, that we will be calling it as an outlier. So is outlier clear, everyone? And how to deal with these outliers will be understanding. We'll be understanding when we were about to learn about this data pre-processing. Okay, to deal with these outliers, whatever the data points which we are having outside this one, if we consider them, the model will be getting confused. Okay, the model will be getting confused. So will not be considering those kind of data points. We'll make sure that those data points are not being considered, and we'll be removing those data points. Okay, we'll be removing those data points, or else we'll be imputing the other data points. Okay, so in this outliers, we'll be having this upper outlier and lower outlier. So this is lower outlier, this is upper outlier. Okay. Okay, and how we work on these outliers? We work based on the central tendency, measures of central tendency. Okay, what are measures of central tendency again? Everyone remembers the measures of central tendency: mean, median, and mode. Okay, mean, median, and the mode. So skewness is done, right? Skewness is done and outlier is done. So what happens is when we're learning about this skewness, it is nothing but again a asymmetry of the data. Okay, asymmetry of the data. Asymmetry is nothing but the right skewed. Okay, the right skewed will be called as a positive skewed. It is positive. This is negative. Okay, this one will be calling it as a positive skewed. This one will be calling it as a negative skewed. Okay, negative skewed. Okay, and coming into normal distribution. In normal distribution, what happens is whatever the mean or else the median which we are having, it will be almost equal or else the same. Okay. In normal distributions, the mean median will be almost lying at at one single point. Okay, at this point only we will be getting all the mean median values. Okay, mean and the median value will be getting. So mean, median, and mode all are equal and located at the center of the distribution. Okay, normal distribution, the mean, median, mode all are equal and they are located at the center of the distribution. Okay, they are located at the center of the distribution. And on the same normal distribution, we can check for the confidence interval also. So confidence interval is nothing but it is a range of values around the sample mean. Okay, around the sample mean. This is a like if you consider, just a moment. Okay, so voice is not clear and also no negative values you're saying. Up to what topic have you understood? So Lakshmi, you're saying that not understanding, right? What topic are you not understanding? All the topics which we have discussed? Voice is breaking. Not understanding. Voice is breaking. Voice is breaking. So from what topic my voice is breaking? Is it from the very first? Is it the same or else is it for normal distribution? Starting 10. Okay, fine. Only today. Fine, guys. It's clear, right? Now my voice is clear. Okay. I think for few others it's clear, I think, but okay, I'll try to repeat the topic once again. Okay. So we have just discussed about skewness. We have discussed about the normal distribution, skewness, and also confidence interval. Okay, confidence interval. Confidence interval. So coming into normal distribution, my screen is not being shared. I'm sharing my entire screen. Now I'm sharing my entire screen. Okay, I'm sharing my entire screen. So what are all the things which until now I have told only about normal distribution, skewness, and confidence interval. Okay, skewness and confidence interval. So coming into this normal distribution, this is the plot of normal distribution. Okay, so in normal distribution the plot will be like this. This is x and y axis. So it is in a bell-shaped curve, right? It is in a bell-shaped curve. So if you are having the curve in a bell-shaped curve, we will be saying that it is the data is symmetrical. Okay, the distribution is symmetrical. We will be saying it is a symmetrical distribution. We will be saying, okay, symmetrical distribution. We will be saying, and also here the majority of the values. The majority of the values. You can see these are all the majority of the values, right? Here the majority of the values will be around the mean, median, and the around in this area. Okay, in this particular quarter only the majority of the values will be having, and here the mean, median, and mode are equal. Okay, and are located at center of the distribution. Center of the distribution is nothing but this center of the distribution. Okay, so what is normal distribution again? Normal distribution or Gaussian distribution is the same. Okay, so normal distribution is nothing but, let's say if you are having a column and I want to check how the data distribution is happening, how the data is being distributed. So now I'll be plotting a plot. Okay, so this will be the curve, and so now I can say if it is in a bell-shaped curve, if my curve is in a bell-shaped curve, I can say my data is being normally distributed, and that distribution is known as symmetrical distribution. Okay, that distribution is known as symmetrical distribution. Okay, and here at the center of the distribution, we'll be having this mean, median, and the mode, which are all equal. Okay, the mean, median, and the mode will all be equal if it is normally distributed, and they are located at the center of the distribution. Okay, this is about normal distribution. Okay, this is about normal distribution. Now moving into confidence interval. Okay, confidence interval. What is this confidence interval? Confidence interval is nothing but it is a range of values. Okay, range of values around a sample mean. You people know what a sample mean is, right? So a range of values around the sample mean in which the population parameter is likely to fall. Okay, so let's say I'm having a sample mean value, and whatever the population values which I'm having, that population values will be falling under that part, under the sample mean. Okay, so that is where we can say, like with the confidence interval is nothing but the population parameter will be in the sample mean only. See, is that clear? So sample mean, let's say this is my whole entire data set. Sample mean means I'll be considering this part, right? Fewer observations, correct? So whatever the sample data I have considered, I'll be calculating the mean for it. I'll be calculating the mean value for it. Okay, mean value for it, and after calculating the mean, and I'll also have the population values, right? Whatever the population values I'm having, if those values are falling inside this mean, then this is what a confidence interval is. Okay, this is the saying of the sample mean. Okay, the saying of the values, the range of values around the sample mean within which the population parameter is likely to fall is known as confidence interval. Okay, so confidence interval is nothing but again a range of values around a sample mean. So this is a sample mean. Okay, let's say sample mean is 15. Sample mean is 15. So the values around this 15, the values around that 15. Okay, the range of values around the 15, and within that 15 we'll be having the population values also. Within the 15 we'll be having the population values, or else which is about likely to fall within 15. Okay, which is about likely to fall within 15. So that kind of saying, or else that kind of plotting. Okay, then if the data is being in that format, if the data is being in that format, then we'll be saying that with a certain level of confidence. Okay, saying that with a certain level of confidence as per the plot is known as confidence interval. Okay, is confidence interval clear and also normal distribution clear? Is my voice clear? What I was explaining? Is it clear, everyone, guys? Is it clear? Guys, for the people who are not able to hear clearly, please try to check your internet once. Okay, please try to check your internet once, and if your internet is stable, it's fine. So please stay until 4:30. Okay, don't leave the session. At the end of the session, you can ask the same dot. I'll be repeating it. Okay, fine. So after that, let me just enable my screen share again. Okay, now my screen is being shared. Now we're having this. Okay, then we have discussed about skewness. Skewness means we'll be having two different types of plots. Okay, in skewness we'll be having two different types of plots. Okay, left skewed. This is left skewed. Okay, left skewed, and this one is right skewed. Okay, left skewed and right skewed. Okay, left skewed and right skewed. So skewness is nothing but when the data is normally distributed, we will be saying it is symmetrical. And here, when the data is not normally being distributed, we will be saying it as asymmetrical kind of data. Okay, asymmetrical kind of data means when the data is not being normally distributed, and if there is any skewness present, then we will be saying it as an asymmetrical. And if the data is distributed normally, then we will be saying it as an symmetrical data. Okay, symmetrical data. So yeah, so that is about the limit theorem level normal distribution. Okay, so then comes the type 1, type 2 error. What is this type 1 and type 2 error? Yesterday did we discuss about type 1 and type 2? Okay, we did discuss about type 1 and type 2, right? So we'll be having in statistics type 1 error, type 2 error. Okay, so what is this type 1 and type 2 error? So the p-value is a probability value, right? P-value is a probability value, right? Which will be measuring the strength, right? Which will be measuring the evidence against the null hypothesis, correct? So in this type 1 error, it refers to rejecting a true null hypothesis. Okay, refers to rejecting a true null hypothesis. And coming into type 2, what is this type 2? Type 2 nothing but it occurs when a false null hypothesis is rejected. It occurs when a false null hypo is rejected. Okay, So what exactly is this type 1 and type 2? It is differing that rejecting a true null hypothesis. So when the null hypothesis is true, but we are rejecting, so we got an evidence that null hypothesis, whatever the statement which is assumed is true, but if we are rejecting that statement and accepting the alternate, then that kind of error is known as type 1. And type 2 is nothing but it occurs when a false null hypothesis is rejected. Okay, so what it is saying, it is actually so false null, right? When a false null hypothesis is rejected. So the null hypothesis, actually whatever the null hypothesis which we are assuming is already false. Whatever the statement in the null hypothesis is present, assumed statement is present, is not correct. It is not correct. And the particular statement is rejected. Okay, so those kind of thing is known as a false null hypothesis. It is nothing but meaning a failure to detect a significant effect. Okay, a failure to detect a significant effect or relation, which actually existing, which is actually existing as per the data. The medicine works. Okay, but the assumed statement is the medicine doesn't work. Okay, and even the assumed statement means the null hypothesis. It occurs when a false null hypothesis is rejected. The thing is, just remember this, okay? A failure to detect a significant effect or relationships, okay? Failure to detect, let me just write it. Failure to detect a significant effect or relationships that actually exist. Okay, this is about type 2, type 1 and type 2, okay? So this is pretty much about type 1 and type 2. You can see failing to reject the null hypothesis when it is actually false. When it is actually false, but we are failing to reject that null hypothesis. Okay, so example is medical test to fail to detect a disease when a person is actually having. So when a person is actually having, but you are failing to detect that. So those kind of errors will come under type 2, okay? So type 1 and type 2, when we are doing hypothesis testing, we'll be getting this type 1 and type 2 error, okay? Okay, so is it clear, guys? Is it clear whatever the things which we have discussed until now? We have discussed only 4 topics. See, Chendu, it's not like where do we use this in AI. It's like on what kind of data, what are all the things we need to perform, okay? We are about to dive into machine learning, but in order to work on the data set, we need to understand the data. See, everyone can build a model. Everyone can build a model, but everyone can't understand the data, okay? Everyone can't understand the data. So to make sure we are understanding the data and we are taking the right measures, so that is why we'll be using all these statistics things, okay? In order to develop the POC level also, we'll be using all these statistics measures, okay? Is that clear, Chandu? Is that clear, Chandu? Okay, how many of you are clear with this concept? Just drop a reaction. Okay. Okay, fine. Thank you. Fine. Thank you, guys. So now, so we are done with that prerequisites for machine learning. Okay. Now we will dive into data pre-processing. Okay, we'll dive into data pre-processing, and we'll just discuss the what are all the things which are required in data pre-processing, and then today, if time permits, we will start with the notebook. If not, tomorrow we'll do the notebook, and also we'll deep dive into data pre-processing. Okay. I'm sharing my screen. Just a minute. Fine. Okay, data pre-processing and cleaning. This is the major step. Okay, this is a major step. So we'll discuss this machine learning. Did we discuss the machine learning life cycle? Did we discuss the machine learning life cycle, guys? Okay, fine. Even if we discuss or not, initially in the machine learning life cycle, the very first step is defining the problem statement. Okay, defining the problem statement is the very first step in machine learning. And after defining the problem statement is nothing but understanding that problem statement. Okay, and after understanding that problem statement, what we need to do is exactly we need to what was the problem which we are trying to solve and what was the solution that we are trying to come up with. We need to collect the data related to that problem. Okay, related to that problem, we need to collect the data so that once the data collection has happened, we can do the pre-processing and we can further proceed. Okay, so now what we'll be doing is we'll be discussing about data pre-processing and cleaning. Definitely, if you are in a company, we'll be getting to know about the problem, and as per the problem, we'll be provided with the data, right? So, understanding the problem and data collection, two steps are done. Okay. Now, coming into data pre-processing. Data pre-processing. So, we'll just go through the slides, okay? And what it is saying, data pre-processing and cleaning are essential steps in any data analysis or machine learning pipeline. There were essential steps in the machine learning pipeline. Okay, because data pre-processing is very important. See, building the model is one thing, understanding the model is other thing, but data pre-processing is the biggest thing. I just want to say this. So, in mostly, if you are aware of any machine learning engineer, your circle, so please just ask him like how much time will it take for them to do the data pre-processing. Will literally take, so let's say there is a 4 weeks time limit for the project. In that case, they will take around 2 to 3 weeks for data pre-processing only, okay, or else 1 to 2 weeks for data pre-processing. After that only they will be building the model. Okay, so data pre-processing is very very important. Okay, because it will helps us to identify and addressing the issues with the data, and also we can ensure more accurate and reliable insights. Okay, so if my data, whatever the data, so normal distribution and the skewness, if you see those two diagrams, in skewness we can't say much about the data. In normal distribution we can say much about the data, right? We can get much more insights from the data, correct? So that is why data pre-processing is important. Even for the, I have also shown you outliers concept. So even for outliers also, removing the outliers is important, and that thing will come under the data pre-processing only. Okay, just move further. So understanding the data quality. How to understand the data, okay? So what are all the three things which are being specified over here? We need to identify the data issues and access whatever the data access the data validity and understanding the data limitation. So what is this? Identifying the data issues, access the data for missing values, outliers, and inconsistencies that could impact the analysis. Okay, inconsistencies that could impact the analysis. So what are all the major keywords here? Missing values, outliers, inconsistencies that could impact analysis. Okay, inconsistencies that could impact the analysis. And what is the second one? Access the data validity. So what it is saying, ensuring the data accurately is representing the real world phenomenon and it is meant to capture. So this one is very important again. So let's say I'm having a data, okay, and I'm trying to solve a problem. I'm trying to come up with a machine learning model where I want to predict if a film is average, good, bad, okay. But whatever the data I'm having the data of a drama company, okay. I'm having the data of a drama company, but I want to do build a model related to machine learning, and the domain is film industry, okay, cinema industry. I'm having a details of drama company or else a web series related, not web series, let's say drama company, okay. Now, if I'm having that kind of data and if I want to build a model related to cinema prediction or else film rating prediction, will it work? No, right? It won't work, correct? So we need to make sure whatever the data which we are accessing, that values I mean that data is relevant to the problem or the solution that we are trying to come up with. Okay, so that is what the assess data validity is. Okay, coming into understanding the data limitations. So what is this understanding the data limitations? What it is saying? Recognize the biases or constraints of the data that may affect the insights drawn from it. Okay, so it is nothing but what is the data limitations is nothing but the biases or the constraints of the data which will affect the insights. Biases is nothing but so bias is terminology. What is this bias? Which is not tending to only one part, okay? Which is not tending to only one part, okay? Because it will be affecting the insights. It will be affecting the insights. See, if I consider my data, remember the skewness plot. So in the skewness plot, in the left skewed plot, if I consider that plot as a normal distribution, and I think like my data is normally being distributed, and I try to build a model, what happens is I won't be able to. My model won't be able to predict perfectly. Okay, so that is called as bias. My model or else my data should be normally distributed, and once it is normally distributed, we can draw the better insights from the data, correct? So we need to understand the data limitations also. Okay, identifying and handling the missing values. Identifying and handling the missing values for this, I will say like how to identify the missing values and how in which format the missing values will be, and I'll be explaining like what are all the central tendency measures we can use and what kind of data type. Okay, those things I'll be discussing after the break. Okay, after the break I'll be discussing, and we just have a 10 minutes of short break, and in between this short break I'll be sharing the attendance link. Okay.
Hello everyone, the attendance link is shared. Not working. The attendance link will be activated. Please wait. Please have patience.
Okay, just wait, guys. Just wait. We'll be checking. Okay, I'll check with the team once. Just have some patience. Okay, just wait, please. Okay, guys, now the attendance link is working fine and the QR is also working fine. So please do mark your attendance, okay? Do mark your attendance. Just give another 5 minutes, okay? Do mark your attendance. And the link will be active up to 4:30, okay? Need not to worry, okay? Guys, please don't share that snips, okay? If it's fine if you have marked your attendance, but please don't share those snippets, okay? Okay, I hope everyone are done with their attendance, right? So now we'll be discussing about this data pre-processing, and in the data pre-processing, we'll be discussing especially about missing values and how to deal with the missing values. Okay, I'll share my screen. Okay, fine. Now this is important. Okay, now whatever I'm about to say, this is important. Okay, just a moment. I'll share my OneNote. I will clearly discuss about this thing. Okay, this is very important, guys. So I don't know if you people are understanding the other topics, but understanding this data pre-processing is very important in order to deal with the machine learning. Okay. Okay, fine. So now let's consider we're having a data set. Okay. So can anyone just suggest me any domain? Can anyone suggest me any domain? Be it related to anything. Be it anything. Can anyone suggest any domain? Drop it in the Q&A chat. Okay. Okay. AI, data science, stocks, employee, machine learning, AI. Huh? So the domain itself you're saying AI? IoT, yeah, IoT we can say. Good one, Hemalata. Yeah, music we can say good one, Anusha, and good one, Sheikh, healthcare we can consider. So can I consider sales? It will be easy for everyone to understand. Can I consider sales? Right? Okay. So as this is a summertime, so so in the during the summer period, everyone will be craving for ice creams, right? Everyone will be having that cravings, right, for ice cream. So I'll be considering that data. Okay, I'll be considering that data. So I won't be switching all the time, but whatever the thing which if I say like if it is clear, do let me know. Okay, if it is not clear, what are the point which it is not clear, just drop it in the chat right away for this data pre-processing. I'm opening my OneNote. Yeah. Now I'm considering my domain as sales, and I'm considering the time period is, I mean, the data which I'm having, I'm saying it is related to ice cream sales. Okay. Ice cream sales. Now, in this ice cream sales, what could be the columns? What could be the columns? See, one column will be the type of an ice cream. Type of ice cream, right? Type of ice cream. And what could be another column? Another column could be brand of an ice cream, correct? Brand of an ice cream. Brand of an ice cream, type of an ice cream, and the location of that particular location where the particular, see, some of the ice creams we'll be having in few of the locations we'll be finding only a few ice creams, or else sometimes in all the locations all the ice creams are present. But the same ice cream of the same brand will be good in one location, and the same taste we won't be feeling in another location. Did you people experience that? Okay, so we can consider the locations also over here. Okay, locations. Okay, locations. And now Just a moment, guys. I'm sorry. Guys, whatever the Telegram group which you are in and whatever the Telegram link which I have shared, okay, only we are having the only one single group, okay, only one single group we are having, only one single group we are having, and please do not do such kind of things. Don't spam. Please don't spam, and whatever the links which have been updated by other users, so you'll be getting the links from the Smart Bridge team, the daily how you are getting the YouTube links and all those from that profile you'll be getting. So that is genuine, okay. And whatever the files which are being uploaded by the Smart Bridge, only that links, please open those things, okay. What are the other links which you are getting to see, please ignore that. I don't know why those people are spamming like that, but please do ignore those things, okay. And this is the only one group which is present for AML, okay. There is no other groups, so please don't spam, okay. It's clear for everyone. So coming into the domain ice cream, this is our ice cream domain, and I'm having the brand of an ice cream, I'm having the brand of an ice cream, the type of an ice cream, and I'm having the locations, I'm having the location, and here I'll be having the price, okay. Here I'll be having the price. So this is my entire data set, okay. This is my entire data set, okay. What are all the things I'm having? Brand of an ice cream, type of an ice cream, location of the ice cream, and locations of those brands available in a city. And also P is nothing but the price, right? P is nothing but the price. So in this, let's say in a column, I'm considering a column called brand ice, okay? Like brand of an ice cream. So brand of an ice cream, okay? Brand of an ice cream. Brand of an ice cream means the ice cream brands, right? What are all the ice cream brands we are aware of? Mostly everyone is aware of Arun, Hamor, and also NIC, Naturals. Correct. These are all the major brands which we will be getting to see. Correct. So let's say one is Arun and one is Ibaco. Sorry. Arun, Ibaco, Naturals, NIC. So these are all the brands, right? These are all the brands. So let's say I'm having a value where it is NAN, okay. This is also a brand. This is also a brand, but the brand name is not updated in this particular column called brand ice cream, okay. In this brand ice cream, this particular brand name is missing. The particular brand name is missing, and if that particular name or the value is missing from that particular column, we'll be calling it, you'll be seeing NAN over there, okay? NAN. NAN is nothing but not a number, okay? NAN is nothing but not a number. So not a number. In that case, wherever we see NAN, that means in that column, that particular value is a null value, okay? And we can get to know the null value count also, And how we can get to know the null value? and how to read the data set, that we'll be seeing. Okay, once we are done with this explanation, by 4:10 I'll be completing with this missing value explanation, and after that I will try to import a data set, and then we'll be seeing how to read the data, how to read the particular data when we are having the file from a comma separated value file, that is a Excel file or else a text file. Okay, I'll be explaining that. Okay, I'll be showing that. So if in my column I'm having a value as NaN, then that is a null value. Okay, that is a null value. So what kind of column it is? What kind of column it is? It is a categorical. Textual column is a categorical column, correct? Textual column is a categorical column. So that means that I need to so initially I'm having a null value, so I need to replace that null value, correct? So in order to replace the null values, we'll be replacing the null values as per the column. Okay, we'll be replacing the null values as per the column. So let's say not let's just say, so here you can clearly see I'm having a column which is in a categorical, text format. Okay, I'm having a column, the brand of an ice cream is in a textual format, correct? So that means that I need to replace it with a which value, what kind of value I need to replace it? Do I need to replace this missing value with a null value? The missing value over here with a textual value or else a numerical value? What kind of value I can replace with? Can I get to know in the Q&A, guys? What kind of values I can replace with? See, in a column, I'm repeating the question once again. Please listen. In a column, I'm having a null value. Okay, one of the value is null value, and the example which we are considering is ice cream example, and the column is brand of an ice cream. Brand of an ice cream means we are having our own Ibeco, all those brands, right? So now the thing is, one of the value is null value. Okay, one of the value is null value. So now there should be no null values when we are passing our data to the model. Okay, so I need to replace that null values. Okay, replace or impute the null values. Imputation we'll be saying, imputing we'll be saying. I need to impute the values wherever I'm having the null values. I need to impute the actual values. Okay, the column is a textual kind of a column. So now my question is, what kind of imputation I need to do? Do I need to do a categorical or else a numerical? See, Chandu, NaN is not a number, and that means missing value, which is not a number, and that means a missing value. Okay, that is what it is. Yes, correct. Thank you, Durga, and thank you, Shiva. Okay, so hopefully you are listening to the session. Thank you. Thankfully. So this is the brand of an ice cream, right? This is the brand of an ice cream, and I'm having a missing value over here. And remember, missing values will be represented by NaN. NaN means not a number. Okay, I'm having a missing value, so I need to replace the missing value. In order to replace the missing value, I need to replace it with a textual only. Correct. I need to replace with the textual content only, because the column which I'm having is also categorical column only. So I need to replace what are the missing values with the categorical values which are present in that column only. Now, remember the measures of central tendency. Mean, median, and mode. So when we want to replace the null values, in textual data, in categorical data, we'll be using mode. Okay, we'll be using mode. Okay, what is mode here? The most repeated or the frequently repeated value. Correct. So let's say in my brand of an ice cream column, Arun is repeating 6 times. Okay, Arun is repeating 6 times. Ibeco is repeating 3 times. Naturals is repeating 2 times, and NIC 1. Okay, NIC 1. NIC is 1. Okay, so if I apply mode for this column, what will be the answer? The mode is Arun, right? It is repeating 6 times. So if I need to replace a missing value, for this missing value, this will be replaced with Arun. Okay, and again here also I will get this NAN will be replaced with Arun. Okay, Arun. Is it clear? So imputing the missing values. How to impute the missing values is not. We'll see the syntax for that. Okay, but in categorical column we need to how we will be doing. This is what I have explained. Okay, in categorical column or else in a textual column, we will be considering central tendency, measures of central tendency, and from the measures of central tendency we will be considering only mode over there. Okay, we'll be considering mode because we are dealing with the textual data. So we will be considering mode, and whatever the most frequently or else the most repeated value which is present, we will be replacing the null value, or else we'll be imputing the null value or else the missing value with the most repeated value. And how we will be finding the most repeated value? Through measures of central tendency by mode. Okay, so let's say I'm having another column called as price ice cream. So let's say price. Okay, for now just consider price. Okay, just consider price. Into price. So price I'm having around numerical values, or else age group we can consider. Age group of people, what kind of age people who are coming into the ice cream stores, into Arun, into Ibaco. So let's say I'm having around 18, 12 for Ibaco, and 13 for naturals, and 24 for NIC. So we are replacing this with Arun, right? So for Arun, what is the value? 18, right? So 18, correct. So now this is a numerical column. What is the numerical column values for the age group? Mostly for Arun it is 18, for Ibaco it is 12, and for naturals it is 13, and for NIC it is 24, and for the missing value we have replaced it with Arun, right? So the value will be 18 again, correct? It is again the same, right? And this will be changing depending upon the location. Depending upon the location, it will be changing. If the location is the same, then again this will be 18 only. Okay. So let's say for Arun only, the 18 age group people are coming, and there is another value which is NaN. Okay, there is another value which is NaN. So in that case, again if I want to replace this NaN, can I use mode? Can I use mode over there? Can I use mode over there? Was my question clear? I'm having a numerical column, okay? I'm having few values. Over there. But one of the values is NaN in the numerical value. Can I use mode? Median or mean? Median or mean, right? So when to use mean and when to use median? When to use mean and when to use median? Remember the concept when we are discussing about the types of data, qualitative, quantitative. Remember that concept? Remember discrete and continuous data? Let me just show you this one. This one only, right? Remember this discrete, continuous, typically counted, certain range. What is this discrete and what is this continuous? Remember? So this one will be helpful here, okay? Understanding, guys? So that what kind of depending on the type of the column which I am having, and understanding the type of the column, it is a discrete or continuous, and based on that understanding, be doing the null values replacement. Okay, I'll be doing the null value replacement. Either I will be going for mean or else median. Okay, either I will be going for mean or median. Okay, so if it is continuous, mostly and also depending upon the domain. Okay, it's not like if it is continuous, I can go for mean. If it is discrete, I can go for median. It is not like that. Okay, it completely depends on the domain and the type of the problem statement that we are coming up with. Okay, it completely depends on the data which you're trying to solve. Okay, on the data which you're trying to solve. So that is how you replace the missing values for numerical and categorical. Okay, you replace the missing values for both numerical and categorical. So now the thing is, so now we got to know like how to impute the missing values in both the numerical and categorical. Now we just get to know about now we'll get to know about this topic, that is just a moment. Now we'll get to know about when to keep a column and when to drop a column. Okay, when to keep a column, when to drop a column. Okay, so this is the data set I'm considering, right? Brand of an ice cream, type of an ice cream, locations and price, right? So now let's say I'm having a column like can anyone say any irrelevant column over here in this data? Can anyone say any irrelevant column? See, Veera Venkatas, I am not sure it's your name. The class is already been going on from 3:40. Okay. In between, we took a short break, but from 3:40, the class is going on. I don't know where you are. Okay. Fine. So let's say there is another irrelevant column called as name. Okay. Name. Called as name. Is name relevant over in this particular data? No, right? Name is irrelevant because in order to know which is relevant and which is irrelevant, we need to understand what is the major difference between an independent column and a dependent column. Anyone know about this independent and dependent column, guys? Independent and dependent column. See, I'll just explain now. So independent and dependent column. Independent and dependent column is nothing but so if you look at this brand of an ice cream, it is completely independent of itself, right? It is not depending on any other column. The value which we are having in the brand of an ice cream, are completely not dependent on any other column values, right? So then we will be say this is independent. Okay. And type of an ice cream will have vanilla, butterscotch, and red velvet, or all those chocolate. All these ice cream types will be having, right? So it is also completely independent. Okay, every brand is making those types of ice creams, right? So it is also completely independent. And locations, depending upon the locations, will be having different brands and different types, right? So this is also independent. And price, is price independent or dependent? Is price column depending on the other columns or else it is on its own? Can anyone let me know? Okay, serial number we can consider. Thank you, Tejasri. Thank you. Serial number we can consider as an irrelevant data. So now, everyone, please let me know in the Q&A. Is the price column a dependent column or else an independent column? Is price column a dependent column or else an independent column? Is it independent or dependent? Okay, I got one answer as dependent. Independent, dependent. So dependent, independent. Correct. So Lakshmi, you're saying that dependent on brand or the flavor. Correct. So thank you guys. Thanks for the answers. And price may be different. Okay, fine. So now The price column is the price will be differing as per the location, as per the type of an ice cream, and as per the brand of an ice cream, right? As per the brand of an ice cream. So now the price is dependent on all these columns. See, let's say I went to watch a film. Okay, I went to watch a film in a multiplex. Okay, I want to watch a film in a multiplex. So in the multiplex, the average rate of a particular ice cream will be different, correct? Or else the average popcorn price will be different when compared to other popcorn prices, correct? So it completely depends on the location, the type of the ice cream or the type of the popcorn which I'm buying, and there will be the brands of the ice cream or the brands of popcorn. Okay. So depending on all these factors, the price is decided. The price is decided. So price is dependent. Okay, the price is dependent. And coming into name or else the serial number, it is completely again irrelevant to this data. You know, so whatever. So the dependent column will be the target column over here. Okay, target. This is irrelevant data. Just don't consider this column now. Okay. Don't consider this irrelevant column now. Let's say we are having up to only price. Okay, we are having up to only price. Okay, we are having up to price. So this price is dependent, right? That dependent column we will be calling it as a target column. Okay, target. That dependent column we will be calling it as a target column or else a target variable. The columns we can call it as a variable. Columns we can call it as features. We can call columns in features. Mostly we'll be addressing them as a features. So everyone understood a difference between a independent and dependent, independent and dependent. Okay, so as I'm having price column as price column will be in numerical, right? Price column will be in numerical. So that means I'm dealing with what kind of problem? I'm dealing with regression. Okay, I'm dealing with regression. So depending on the type of the target variable, we'll be going for regression or the other one is classification. Okay, regression or classification. So need not to worry about the regression and classification. Okay, we'll dive into the topic. Okay, we'll dive into the topic. Fine. So guys, confirm me one thing. Did we discuss about these types of machine learning, supervised, unsupervised, and reinforcement? Yes or no? Yeah, fine. So in supervised learning, we'll be having two types. Okay, regression and classification. Okay, regression and classification. Few people are saying yes, few are saying no. Yes or no? No. Okay. Okay, that is fine. Okay, that is fine. So this is a machine learning steps. Okay, these are all the machine learning steps. So what are all the steps we are seeing over here? So machine learning life cycle initially will be defining the problem statement. Initially we'll define the problem statement, data gathering or else collecting the data points. Okay, data gathering we'll be having, and then data pre-processing. In the data pre-processing, we'll be cleaning the data. Cleaning the data. How will be cleaning the data? We'll be handling the missing values. How will be handling the missing values? We'll be handling the missing values depending upon the column. Okay, depending upon the column, we'll be handling the missing values. Okay, and if it is a categorical or a numerical, based on that, we'll be handling the missing values. And coming into this not feature engineering, there is a few more concepts to discuss in cleaning data. Okay. Okay, fine. We'll discuss about that. So now I'm having this irrelevant column. Okay, now I will consider this irrelevant column. Okay, and let's say this location column is having around more than 30%. Okay, more than 30%. Okay. Yeah, I'm sharing my screen. Sorry. Yeah, Jagdish, removing and handling the null values, there is much difference. Okay. Till now, we have discussed about handling the null values. Okay. So let's say for locations, for the column locations, so this is an irrelevant column, right? Name is an irrelevant column, or serial number is an irrelevant column over here, because we'll already be having this index column, right? We'll be having the index column. I mean, we'll be having the indexes. So whatever the column, whatever the data set which we are having, we'll be already having the index, okay? So need not to keep the serial number column again, okay? So that is an irrelevant column. And coming into locations, let's say I'm having around 30% of the null values, okay? 30% of the null values. Now, if I'm having around less than 15% of the null values, less than 15, I'll be handling the null values, okay? I'll be handling the null values. And if my null values are around less than 1%, or else if I'm having a data around 10 lakh plus rows, 10 lakh plus rows, so if I'm having the null values around less than 1%, then I can directly remove the null values, okay? I can directly drop the whatever the null values which I'm having. I can drop that whole row. Whole row will be dropped, okay? Whole row will be dropped, okay? And if I'm having around less than 15% or around 30, okay, less than 15 to 30 or else 5 to 30, let's say 5 to 30, okay, 5 to 30% in between I'm having the null values. I'll be handling those kind of null values, okay? I'll be handling those kind of null values, okay? But if I'm having null values more than 30%, more than 30% if I'm having, I can directly drop that particular column, because let's say in a column I'm having 100 values, 100 values I'm having, 100 values I'm having. In that 100 values, 30%, 30 values, right? So for these 30 values, if these 30, all the 30 values are null, then what is the point of using that particular column? What is the point of using that particular column? So in that case, I can drop that column, okay? Dropping is the solution. We can drop if the null values are greater than 30% present in our column, I can drop that particular column. But there is a catch here, okay? What is the catch? If that particular column is making an impact, in order to understand the underlying patterns, okay, if that column is making an impact, it is helping us to understand the patterns, it is helping the model to understand the things. So if you feel like that column will be helpful for understanding the model, then even if the missing values are more than 30, we'll be just handling this, okay? Even if it is this, we'll be handling the missing values, okay? We'll be handling the missing values. Is it clear, guys? If it is less than 1% and if you are having a huge amount of data, we can drop that 1%, okay? We can drop the null values, okay? And if the null values are greater than 30%, we can drop the column. But if the column is making an impact, if the column is important, then instead of dropping, we'll be filling that with the, we'll be imputing the values, okay? Is that clear? Handling the missing values, is it clear? How to handle the missing values, is it clear, guys? Okay, I hope it's clear for everyone. And one more thing, in our data also, we'll be having duplicates, okay? In our data, we'll be having duplicate values also. In order to check the duplicates also, there is a syntax, if the data frame name is df, it is like df dot duplicates dot sum, okay? So that we'll be getting what are the duplicates values which we are having, which are present in the whole data set, okay? Which are present in the whole data set. So this is mainly about missing values, okay? This is mainly about missing values. And here we'll be having a concept called IQR, okay? IQR concept we'll be discussing tomorrow, okay? IQR is nothing but interquartile range, okay? Interquartile range that we'll be discussing tomorrow. IQR, which is important, okay? IQR is important. We'll be discussing that tomorrow. So today we have discussed about normal distribution, confidence interval, skewness, and also we have dived into data gathering, data collection, understanding the problem statement, and also missing values, how to handle the missing values. Correct. So I'll answer your query, Chandu, just wait, okay? Fine. So, is there any topic left over that I haven't mentioned? Is there any topic left over that I haven't mentioned? These are all the topics, right? Today, these are all the topics which we have discussed, right? Okay. See, skewness means what are the flat line that you're seeing? That is the skewness, okay? Okay. Yeah, that's it for today, guys. That's it for today. Even if it start a new topic now, it will be taking much time. So that's it for today, okay? Fine. So now do let me know whatever the queries you're having in Q&A and chat, okay? Hope everyone understood the session. Hope everyone understood the topics. We were discussing only few topics a day, but it's totally fine, okay? Central limit theorem. We forgot that central limit theorem. We forgot type 1, type 2 error. Correct. Are people listening to the session, right? Outliers, yeah, outliers, okay? It is outliers. It is outliers, okay? Liars. Outliers, not outliners. It is outliers. Lying outside, okay? Lying outside. See, missing the previous session, we discussed all the prerequisites for machine learning, okay? But those are all important concepts. Those are all important concepts, okay? There will not be any problem. There will not be any problem, but try to cover those topics, okay? So whatever the queries you are having, please do let me know, okay? Whatever the queries that you are having, please do let me know. And also, I have created a poll, okay? Whatever the topics which you understood, please do let us know, okay? Telegram group, where can I get the notes? Vijay, I'm sorry, I haven't uploaded the notes, okay? I will be uploading the notebook notes today, okay? I'll be uploading the notes today. And so, Sushila, is the IBM certification done with for getting started with AI? For all the 3 courses, are you done with the certification? Scaling, I will explain Teja, okay? Tejas, I will explain scaling, okay? Don't worry. Feature engineering, scaling, all the concepts, label encoding, correlation, heat map, I will explain them, okay? Don't worry. Yeah, definitely I will share the notes, Tinti. Definitely I will share. So Vaishnavi, you are asking, please send the video process how to get the certificate by using link. See, Vaishnavi, there will be no video process on getting that certification, but the thing is, there is a video of a registration into NASCOM, okay? Then we can share if you're asking for specifically for a video process. I mean, and coming into IBM, sorry, in IBM, you people have received a link in through Telegram, right? So if you click on that link, you will be initially asked for sign in and sign up. Okay, so you just need to sign up and sign in. You need to sign up if you haven't signed up, and you need to sign in again. And you can go through that link. Okay, you can go through that link, and please enroll in that. Okay, if you go through that link, you'll be getting to see getting started with artificial intelligence. We'll just share the screen, okay? Yeah, I will be sharing the notes in Telegram only, okay? And the same SmartWest group only I will be sharing, okay? Okay, so if you see here, after sign up and sign in, you'll be having that link, right? If you click on that link, you'll be directly redirected to this getting started with artificial intelligence, okay? Getting started with artificial intelligence. And once, if you got to see this particular tab or its window, then you'll be seeing an option called enroll over here. Enroll, okay? It is unenrolled right now, but enroll in that particular course, okay? Enroll in the particular course. And in this course, we need to complete these three courses, okay? In that particular whole course, we are having these three shorthand courses. What are all these three? Introduction to Artificial Intelligence, Large Language Model Basics, Mastering the Art of Prompting, okay? These three courses you need to complete. And once you complete all these three courses, parallelly, what you need to do is you need to create the Credly account, okay? You need to create the Credly account. So, in order to create the Credly account, what it is saying, create a Credly account, just click on that. Just click on that. Yes. So here, you'll be having the details, okay? If you don't have a Credly account, complete these steps to create one and claim the credentials you have worked on. And one thing is access the Credly, sign in, or else if you're not having an account, create an account, enter the details. And this is how you'll be creating a Credly account. And once the Credly account is created, you'll be able to see your certificate. Okay, what certificate? The three courses which you will be completing, right? That certificate you will be able to see. Okay. So hopefully it is clear about Credly and this IBM. This is like a second time we are repeating, but that's fine. I hope it's clear for everyone. No reply. What happened, Mohan Chandra? Okay, so coming into, you're saying that post videos, some of my friends want to watch a notes PPT. See, that is what I was saying, Mohan Chandra. Coming into this notes, the collab notebook which we have discussed, that I will be updating in the Telegram group by the end of the day. Okay, I'll be updating that. Okay, I'm sorry. Okay, so it's fine, right? You understood, right? I'll be uploading by the end of the day. Okay. Okay. Okay, fine. Any other queries? Any other queries? No one is having any other queries, do let me know. So I didn't attend today and the day before because I didn't get the link. So Nageshree, whatever the mail that you have registered with, so through that mail only you will be, to that mail only you will be receiving the session links. Okay. And every day in Telegram group, you will also get the YouTube link. Okay. Every day in Telegram group, you will also get the YouTube link. You can join through YouTube also. Okay? It's totally fine. Telegram link. Okay. Yeah, we'll be sharing you the Telegram link. No, there is no problem, Charmi. Yeah, there is no problem, Charmi. So, no, it's fine if you have another mail from college. If you're computer, it's fine, okay. But make sure you're using one single email for whatever the communication which is happening over here, okay. Previously, for chatbot, the link was updated, but yesterday that has been rectified. Okay, later the AML getting started with artificial intelligence link was updated. Anyone, any other queries related to today's session? No, yes, no. See, that is what I told Charmi. There is no problem. Okay. No problem. No. It's fine if you have already completed AML course. Okay. It's fine if you have already completed it. Okay. So whatever the topics which we have discussed, is it clear? And again, we have updated the self-paced learning link. Please go through that link. Okay. Okay. Sheikh, you saying that? Okay, so getting started with building its dominance, so building a chatbot, getting started with artificial intelligence introduction to dynamics. So building your first chatbot, why that is coming, I don't know. But once you click on the course, you'll be having go to activity, okay? The activity, and from there you can do the things, okay? See, you're having this go to activity, right? Once you click on that course, Introduction to Artificial Intelligence, and once you click on this Go to Activity button, you'll be navigated into a new window. Okay, you'll be navigated into a new window. I had just clicked on that Go to Activity. Just wait, the screen is loading. Yeah. So this is the new window, Start Course, and once you click on Start Course, the course will be started. Okay, you can start the course. Okay, and you can have all the course overview about earning a credential, and how AI is evolving, what is the phase, okay, all these things you'll be finding. You need to click on that course, you need to click on go to activity, and you need to start your course. That is how you start your course, okay. Clear, Sheikh? I'm sorry, I'm not aware with Jayesh. Is it clear for you? You are the one who just kept this whole message, so is it clear for you? Anyone, any other doubts? Okay, fine. So as it is 4:30, once you're not having any doubts, and once you're done with the poll, you may leave the session. Okay, for today, please, you may leave the session. Have a great evening ahead. Thank you, guys. Thank you. Thank you. Thank you. I'm ending the session.